In this video, we're going to continue looking at factoring polynomials using two new special factoring patterns, the sum of two cubes and the difference of two cubes. Now, for both of these, we have to be able to recognize that we've got two perfect cubes and then either an addition sign or a subtraction sign in between them. Now, to make sure that we know what we're talking about when we're talking about the perfect cubes, I've got a list of them for you right here. So here's x and then x cubed. So 1 cubed is 1, 2 cubed is 8, etc., all the way down to 7 cubed being 343. So to go along with the squares that we need to be able to recognize and understand where they come from, cubes are now another kind of number that we should be able to pick out. So the way that the sum of two cubes pattern works is if I have two cubes added together, I can factor that expression into a binomial and a trinomial. So there's two parts to these, binomial and trinomial. In the binomial expression, I've got a plus b. Well, a is whatever I cubed to get this expression, and b is whatever I cubed to get this expression. So the example given to us over here is 8x cubed plus 27. Well, what did I cube to get 8x cubed? Well, I cubed 2 to get 8, and I cubed x to get x cubed. So 2x would be the value of a. What did I cube to get 27? Well, 3 cubed is 27, so 3 must be b. So what happens is I put those two expressions in where they belong. I start out with a plus b in my binomial factor. In the trinomial factor, then I start with a squared. Okay, so 2x is a, and a squared would be 4x squared. Minus ab, that means take these two things and multiply them together. Well, 2x times 3 is 6x, so I put that here. The sign is always going to be opposite the sign that you see in the binomial. So with the sum of cubes pattern, your signs always go plus, minus, plus. You don't have to worry about is it positive or is it negative. That's the way that it goes. With the difference of two cubes, the pattern works the same. It's just that the signs go minus, plus, plus. So you notice that these two things are flipped around based on where they were in the sum of cubes pattern. Other than that, everything's the same. So I have a squared minus ab plus b squared. Well, b was 3 and 3 squared is 9. So I got a 9 at the end of my expression. There it's factored completely. The trinomial part cannot be factored any further, so you don't have to worry about continuing to do anything with that. The difference of two cubes pattern, same thing going on. I have a cube here minus another cube here. I recognize what did I cube to get a 64x cubed? Well, that's 4x. What did I cube to get 1? Well, that's 1. So a minus b times a squared plus ab plus b squared. Here's my expression. Let's put that to work. 125x cubed plus 216. So the first thing I have to recognize is that I have two terms, so this might be a special pattern, and I notice that 125 is a cube, so is x cubed, both on my list, and 216 is also on my list. All right, so I have a couple of cubes. So the first thing I'm going to identify is what did I cube to get each of these numbers? I cubed 5x to come up with 125x cubed, and oops, not just 5x cubed, just 5x. And then I cubed 6 to come up with 216. So I'm going to write a as 5x and b is going to be 6. So then, now that I know what a and b are, I can factor this using my sum of cubes pattern. My first binomial term is going to be a plus b, so that's going to be 5x plus 6. And then the trinomial factor is going to be a squared. Well, that's going to be 25x squared. Minus a times b, well, that's going to be 30x, plus b squared, well, that's going to be 36. Close my parentheses. This is my final answer. Again, when I use the sum of cubes or difference cubes pattern, the trinomial will not be able to be factored further. This is all that we need right here. One more example. Maybe this is the difference of cubes. The problem is, as I look at it originally, 192 is not a number that's on my list, and neither is 3. So sometimes what has to happen is, if they don't look like the cubes or the squares that you were expecting, there might be a greatest common factor that can be factored out of both expressions first. So if I look at these two, let's see, I know 3 goes into 3. I'm going to guess that 3 goes into 192. Well, 1 plus 2 is 3, plus 9 is 12. 12 is divisible by 3. That means so is this number. So I'm going to factor out a 3 from this expression first. Now 3 goes into 192 64 times, so I have 64w cubed. 3 goes into 3 once, so now I got minus 1. Now all of a sudden I've got 1 which I know is a cube and 64 which I notice is also a cube, so I think I'm going to be good to go here. So I identify what A and B are. A is what did I cube to come up with 64W cubed. We'll check in my list. Must be a 4. So 4W is the value of A. And B, what did I cube to get 1? That'd be 1. Knowing those things, I can use my pattern. There will be a 3 in my answer, so I'll put 3 times the binomial factor, which is 4W minus 1 this time because it was a difference of cubes, times A squared, 16W squared, plus AB, which is 4W, plus B squared, which will be a 1. There you have it. The 3 that I took out of the beginning, binomial factor, trinomial factor. This is a completely factored polynomial using the difference of 2 cubes.